Hi everyone, welcome to today's lecture. So in today's lecture we're going to look at differential calculus in details. So we are going to discuss about differentiation from the first principles. We're also going to look at differentiation using the quotient rule, differentiation using the product rule, and differentiation using function, which is also called as the chain rule. So we're going to look at these three parts of differentiation from the differentiation using the function, which is the chain rule, differentiation using the quotient rule, differentiation using the product rule, and also differentiation from the first principle, and also using the general formula. Yes, so we are going to start. So calculus is being defined as the branch of mathematics involving or leading to calculations dealing with continuously varying functions such as velocity and accelerations, rates of change, and maximum and minimum values of curves. So we are going to look at these calculations which deals with calculus when we come to the part actually that will be dealing with this differentiation application of calculus using differentiation. Yes, so differentiation from the first principle, we start. So as we all know that calculus is a subject that focuses into two parts: the differential calculus, which is differentiation, and the integral calculus, which is integration. Yes, so the differentiation actually from the first principle, it has the formula that we do use. So this is the formula that we do use for differentiation using the first principle. You have your dy dx is equals to the lim as h approaches 0, where the f of x plus h in bracket minus the given function over h. So this is the formula that we do use when it comes to differentiation. So you have the lim, so you have dy dx is equals to the lim as h approaches 0, where the f of the x plus h in bracket minus the given function, which is the f of x, you divide by h. So this is the function that, the formula that we are going to use to differentiate any given function from the first principle. You can be asked, actually, you can be given a question to say, using the first principle, differentiate this one to be question 1. Using the first principle, using the first principle, so using the first principle, differentiate, you have 1. We've been given the f of x equals to, let's start with 2x. So you've been asked actually to differentiate this one using the first principle. So how do you differentiate the f of x equals to 2x using the first principle? So you rewrite your formula here, solution. Okay, so you have your dy dx is equals to the lim as h approaches 0, where the f of x plus h minus the f of x over h. So the question says, using the first principle, differentiate 2x. So we were all actually, when we were in the secondary level, we were all looking at, we learned actually differentiation, or we learned calculus actually, how to differentiate such kind of functions using the first principle. We learned even the functions, how to replace if you are given such kind of equation using the functions. So what they're trying to say here is, you've been given that the f of x is equals to 2x, and the formula you have dy dx is equals to the lim as h approaches 0, whereby the f of x plus h minus the f of x over h. In this formula that you have been given, this formula, what they're trying to say, or what they're trying to tell you is, where there is x, you substitute with the x plus h. I'll give you an example of the function, the one we are dealing with in the secondary level. You have such kind of a function. Okay, let's take that this is the function. You have your f of x is equals to 2x. Your f of x is equals to 2x. This is the function that you've been given. Then you've been asked actually to find the f of, let me say 2. This is the question. Find the f of 2. You have been given the question. You have the f of x is equals to 2x. Find the f of 2. So what we used to do is, where there is x, what they're trying to tell you, what they're trying to say is, where there is x, you substitute with what? With 2. So it will be 2, open bracket, 2. 2 times 2, that gives you 4. Meaning, the f of x equals to 2x, the answer is supposed to give you what? Give you 4. Okay, I hope you are clear now. So even on differentiation, that's what we are going to do. Like where there is x in our formula, we substitute with what you've been given in the question. Where there is x in the question, the formula that you've been given, you have the lim as h approaches 0, whereby the f of x plus h minus the f of x over h. So here what they're trying to say is, where there is x plus h, this is the question. So into the question, where there is x here, you substitute with what? Instead of us substitute, because here the question the question it was saying, find the f of 2. So where there is x, you substitute with the 2. Same applies to this to this formula. So this formula just tells you to say, where there is x plus h, you substitute this one into the equation, into the question being given. So where there is x in the question, you substitute with the x plus h. This is what they're trying to say here. This is the kind of communication which is here. Like where there is x, you substitute with the x plus h. That's what we're going to do. Okay, so we come back to our question. So our question says that we're supposed to do what? To solve using the first principle. Using the first principle, we're supposed to differentiate the f of x equals to 2x. So where there is x, we substitute with what? With x plus h. So I won't be repeating the same thing, dy dx, so it will be equals to, so I'll just be writing the lim as h approaches 0. So where there is x in the question, we substitute with what? X plus h. So we write our 2 here. This is our 2 here. You write our 2 here, open bracket. So instead of us writing this x, we are going to substitute with the x plus h. So it will be x plus h, you close. 2, where there is x, we've substituted with the x plus h. Minus, this is the formula that we are following, minus what is the f of x? The f of x have been given, which is this one, because this one is the f of x. The f of x says is equals to what? 2x. So where there is f of x, we substitute with what? With 2x. Let me just put in brackets 2x. You close. Then don't forget to divide everything by h. We're done this part. We are done this part. We have substituted. This is the kind of substitution actually which has happened here. So this is the function, the f of x plus h. So in the function here where there is x, we substitute with what? X plus h minus, this is the function of the f of x, and the function of the f of x, this one, it is 2x. You've been given that it is 2x. So where there is f of x, you substitute with what? With 2x. This is what we have done here. You are done with this stage. The next stage, what are we supposed to do? Okay. We bring down our lim equals to h as it approaches 0. You can multiply this one. This is simple math now here. 2 times x, that's 2x. 2 times positive h, that's positive 2h. What is negative times 2x? That's minus 2x. You divide over, don't forget your h. What are we supposed to do? We have like terms 2x and 2x. We can put them together. So we have your lim as h approaches 0. Sorry, I won't be forgetting this because I just have to be writing each and every stage. This one, it is 0. Sorry, don't think that it's 6. Okay, so I'll be writing each and every stage so that at least you're supposed to be following, because in math, each and every stage, it's a mark. So if you want to attract more marks, you're supposed to be writing or following each and every step, each and every stage. Okay, so we have the lim as h approaches 0. So we correct our right terms. So you have this one. You have 2x and negative 2x. So what is 2x minus 2x? The answer is 0. So this one and this one goes. So together with the negative. So because it is 2x minus 2x, which is 0. So we're going to remain with positive 2h. So we're going to remain with your 2h here. You divide. Don't forget your h. Okay. So we continue. So you have your lim as h approaches 0. You have your h and your h. You can cancel. H and h goes. So what do you remain with? 2. So final answer. You have your dy dx is equals to 2. This is your final answer. Okay, so from the question, if you've been asked actually to solve or to differentiate 2x using the first principle, the answer is supposed to give you as 2. So this was our calculations based on the question, which says using the first principle, you've been given the question, the f of x is equals to 2x, differentiate. So the solution, it gives you 2. Okay, we move to the next question. Okay, this one now, it is complex. Okay, so what about if you've been asked this one, since this the other question, it was question 1, this one it will be question 2. I would like to be receiving comments in the comment box where we're supposed to make mistakes or the kind of communication. So you can be commenting in the comment box what kind of questions do you want us to be tackling actually in mathematics. I would say it's engineering mathematics because it is the broad mathematics actually which covers most of the topics in mathematics. It is broad. It covers most of the topics actually in mathematics. So in the comment box, you can be putting those kind of topics you want us to be covering. Okay. So the second question we're going to look at using the first principle. Okay, what about if you've been given you have 1 over x? Using the first principle, differentiate 1 over x. So we're going to do one more question here. Once we're done with this one, we're going to do one more question. Then we move from the first principle. We look at other kind of differentiation, the general formula, how to use the general formula. So if you've been asked actually to differentiate from the first principle 1 over x, so the formula says that you have your dy dx is equals to the lim as h approaches 0, whereby the f of x plus h, you close, minus the f of x over h. This is the formula that I do use, the formula that I don't forget. Since my secondary level, I was using this formula because it is the one which is easy for me to remember and easy for me to reconcile and to think the way I'm supposed to think. Like, even if I'm stuck somewhere, what are the things that I'm supposed to apply for me, at least to gain something, so that at least I can be able to solve different or complex calculations. This is the formula that I do use when it comes to calculus. Yeah. So now the question says that you have 1 over x, differentiate using the first principle. So we start. You have your lim as h approaches 0. So here, where there is x, we substitute with what? X plus h. Okay, so you write your 1 here over what? X plus h. Don't forget that we're only substitute the question that you've been given. In the question where there is x, substitute with this. This is not the f of 2, but it is the f of x plus h. So where there is x in the question, you substitute with what? With x plus h. Okay, so this is what we have done here. Then the formula says minus. We put our minus here. What is the f of x? The f of x, it is this one. So it will be, here it is the f of x equals to this. Yeah. So the f of x, it is 1 over x. We're done here. And just upon looking at this one, guys, it's simple. You can solve it involving algebra. Yeah. Algebra works here. So what we used to do in algebra, when you have such kind of a problem, you find a common denominator of x plus h and x. That's it. Okay, we write x plus h in bracket x. I think people, they're not going to be lost. Or what you can write is you multiply this one with everything. So you can even write x squared plus xh. Okay, for the sake of our guys actually who are slow when it comes in terms of learning, we can be using this one, because this one most of our friends actually are familiar with simplifying in its when you want to simplify actually in its simplest form. Is it? Yeah, such kind of questions which do come, like it has maybe 5 marks in engineering mathematics and grade 12 math. There is a question actually which do come like you're supposed to simplify such kind of a question, maybe solve the question in its simplest form. This one maybe it is equals to 0, whereby others they do cross multiply and the likes. So this is the kind of calculation we're going to do here, basic. So x plus h into x plus h, that's 1. We're going to remain with x. X times 1. X times 1, that's our x. Minus x into x goes, we're going to remain with x plus h. X plus h times 1, that's x plus h. You close. Okay, I think we're done here, guys. Next step, the lim, don't forget this, as h approaches 0. Sorry. Here we're supposed to divide over h. Don't forget the formula, as in what the formula states. Here we just substituted this and try to solve this when you substitute this one. But don't forget this one, the h here still comes here, goes, yeah. So we have the lim as h approaches 0. So we have this one. This you can do what? You can try to expand. So you have your x, you write your x, this one here, your x minus, sorry, not minus, but negative times x, that's negative x, negative times positive h, that's negative h, over x plus h in brackets, x out, over h. Have you seen that it's simple, guys? You have your lim as h approaches 0. Yeah. So you have your x minus x. What is x minus x? X minus x, that's 0. So this one goes. We're going to remain with negative h. So we're going to have negative h. Wow, this is nice. So, okay, let's multiply this, guys. Yeah. What is x times x? That's x squared. Over x squared. What is x times positive h? That's, this one is x squared. My handwriting is bad, guys. It's bad. I really have to improve on my handwriting. So you have x squared, yeah, minus. So what is x times positive h? That's positive xh. Okay. Don't forget our h over h here. Okay. So we keep on going. So we have our lim as h approaches 0. Okay. So here we can do, I'll do the basic math here because I want each and everyone to get the concept when it comes to this, because most of you guys actually get stuck once you have this part here, like, what am I going to do? No, this is calculus. Algebra cannot work. No, guys. Math, each and every subtopic, each and every topic in math, it's important. Those basics that we learned in algebra, they are very much important. They are very much important, like to take note of. You can simplify a complex question using algebra. So respect that part of math. So we have this stage here. What are we going to do? So we have this one. This is the main division. According to our formula, which has h down. Yeah, this one. This is the main division. So this is the main division. This one. This is the main division here. So we can write our negative h over x squared plus xh. We divide by h. This one. Divide by h. We have this one. What do? Simple math, we cross multiply, but we reciprocate. That's the rule. So we have our lim here. Our lim as h approaches 0. We have our negative h over x squared plus xh. Wow, guys, math, it's so sweet. Like, math, guys, is nice. Once you understand each and every stage, when it comes in solving. Okay, so here we have divide h. What do? We reciprocate. So how do you reciprocate? You introduce a cross multiplication here. Since this one, it is h as a whole number, it has a denominator of 1 down. So that same denominator of 1, which is down here, it will go up. Then this h here, it will go down. That's how we do reciprocate. So it will be 1 over h. Don't forget that each and every whole number, it has a denominator of 1 down. So this is how we reciprocate. So we can cancel this h, and this h goes, will remain with negative. When you cancel your h here, remaining with 1, you cancel h here, remaining with 1. So we're going to have negative 1 remaining. So negative 1 times negative 1, times 1, that's negative 1. So we continue here. We have this one. So you have your lim here as h approaches 0. Okay. So negative 1 times 1, that's negative 1. Negative 1 times 1, that's negative 1. Over what is x? What is x squared plus xh times 1? We're going to remain with the same thing, x squared plus xh. When you reach this stage now, guys, The limb says that as h does what? Approaches 0. So where there is x, we substitute with what? With 0. So we continue. Where there is x, we substitute with 0. So it will be dy dx is equals to negative 1 over x squared plus x open bracket as h approaches what? 0. So as h approaches what? Approaches 0. This is 0, guys, so don't think that maybe it's 6 or something. My handwriting, guys, it's bad, but I will try by all means to improve. Okay, so where there is h here, we do what? We replace with 0. So our final answer, dy dx is equals to negative 1 over x squared, what is x times 0, that's 0. So this one becomes our final answer, negative 1 over x squared. So this one becomes our final answer when you've been asked actually from the using the first principle, to differentiate this question here. Using the first principle, differentiate 1 over x. The answer is supposed to come out as in